kind of trying to squeeze performance out of small language models. And if any of you remember Chris Brousseau, rest in peace, he's left us now, but Chris Brousseau would always say something like, dude, that model could be like, with a little bit of tuning or a little bit of whatever special sauce, it could be better than Sonnet 3 or whatever. And that was kind of the inspiration for this. And he really motivated me to kind of explore the waters here. So let's get into it. So I'm Beric Bearnson. This is my GitHub bio. I build tools that build tools that build tools. Clever, right? No. I also have a blog. That's my GitHub. And then if you want to follow me on Twitter for my hot takes, you can go ahead there. I want to talk about kind of my journey building AI harnesses. And it actually starts before ChatGPT was released. In the summer of 22, I built this thing called Pluto. It was like superhuman, but agent first. It's like an email client, right? And it was supposed to be the goal. This is so silly. I was in college, so forgive me. But the goal was to be able to drive your car and have a voice agent go through your emails and summarize your emails and then respond to your emails for you. So you'd be like, okay, what's in my inbox? Triage it. Tell me like the most important things. And then here's my response, send it back. So it was like, speech to text, text to speech, back and forth. And then we were using, does anybody remember the Da Vinci models from OpenAI? Yes, Todd does. Awesome. So that's what powered Pluto. Then that flopped. So I went to Replay. And Replay was a conversational role-playing harness/agent experience for salespeople. Replay is actually still around. And my co-founders are still working on it. But basically, when you're a new sales rep, you have a hard time getting to learn the product and just talking about it, right? Having good conversational intelligence about a subject. And so Replay, what it did was it put you into a phone call or a door-to-door encounter with a fake customer. And once again, this was done using a combination of like customer service chatbots that have like branching logic and all this annoying stuff, and ChatGPT, or not ChatGPT, but OpenAI's Da Vinci. And then ChatGPT released in November. And we're like, oh my gosh, when this API comes out, we can do crazy things. And from there, we kind of expanded on the platform and added what is now called tool calling, right? So before it was like, every time you want to tell the sales rep this, put in pound, 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 and then the name of this specific word, and then we'll rip it out using regex, and then we'll call it. And we weren't able to really do parameters, but we would try to fiddle with it, and it was really unreliable. And then after leaving Replay, I kind of made what I called Omni. It was like a little hackathon project, and it was basically like what OpenClaw is now, right? But this was still before tool calling, and so it would like generate a Lua script, and then you would read like the old markdown that models would output. They would put 3 backticks, the name of the language, and then the code snippet. So we could regex that out. We'd save that in a Lua file, and then execute it just in time, right? And so Omni was like, it had a SQLite database, and then this Lua execution engine, and then you could get the agent to write the Lua and then execute. It worked kind of okay. It could also write a little bit of HTML and make like little tiny web apps, but I didn't take it any further. And then tool calling officially released, and we're like, holy crap. And that's kind of where we're at now with agents, right? They can do a ton of stuff. After that, I went to work at Artifact after Replay, and there we did some crazy stuff using all the models to do unstructured text analysis and trend analysis, topic modeling. And then right now, I'm working on an agent that is able to understand large construction documents and PDFs. And so there's a vision aspect to that now, which is super exciting. And then today, I'm going to talk about another harness that I just barely made called Local Coder. So that's what brings us to coding with locally hosted AI. So technically every model is a locally hosted AI somewhere, right? It's like serverless actually has servers somewhere. But we're going to talk about the actual models that we're going to host. So huge disclaimer. We don't have Fable at home, Mom. Okay? We're not going to get Fable performance. We're not going to get super good agents that run ultra reliably that you can get like on a subscription. We're not going to vibe code. We're going to actually have to read the code and understand, unfortunately. Okay? And this is free if you don't value your time. Local inference is still pretty slow on many machines. And we will not beat the $20 ChatGPT subscription. It's too good right now. And Anthropic and OpenAI are losing. We all know they're losing money on compute when you subscribe to those platforms. But that's okay. I think there is good news. Everything I'm going to talk about today can run on a decent laptop with 16 gigs of RAM. Okay, you get privacy and you get control, and then you'll learn a lot. So I think those are good enough takeaways. So this is going to change tomorrow probably, right? The landscape of models. But from Google, we have Gemma 4. There's like a bunch of different flavors. Don't know what quantization is, or dense versus mixture of experts. Take a look at the Gemma models, and you can see and kind of pick and choose your flavor, which is really neat. Nemotron from NVIDIA is really cool. If you have an NVIDIA GPU, it's fast, it's awesome. Qwen has been in the news a lot. Take a look at Qwen, and we're going to talk a lot about Qwen today, especially. And then Prism ML is like a derivative of Qwen. It's another lab that does really cool quantization techniques to kind of get, well, they don't get it, but they try to preserve as much of performance as they can of the full-size Qwen models. And yeah, I describe Prism as quantize go burr tiny. So give them a look. So we're going to talk about it. But first, I want to show you Qwen 2.5. We're talking now in the news like 3.5, 3.6, 3.8 Qwen. This is Qwen 2.5. So I'm going to pull up Qwen right here. So this is running on my MacBook right now. You can see it's Qwen 2.5, 0.5 billion parameters, instruct, MLX. This is running on my MacBook. The model is like 250 megs, so very small, right? If I run it, it can spit out 204 tokens per second. I'm so sorry that the text is kind of hard to see on the LED here. So 204 tokens per second here. And this is really interesting, right? You would never use an LLM to do arithmetic, right? You'd want to give it a calculator or something like that. But you can ask it stuff like this. What's the hypotenuse of a right triangle with sides 14 and 54 inches long? Those are just numbers I pulled out of my butt. And it'll go and it'll come up with the formula, and it won't calculate it, and you could just say continue, and it'll go and think. And it comes up with two answers here, which is funny. But the final one it comes up with is 56.02. The actual answer is 55.79. It's pretty close, right? That's pretty close? That's pretty astounding though, right? Like a quarter of a gigabyte in model weights can do a square root on arbitrary numbers. Super close. And if you run it again, it might get it wrong, but you keep running it enough, it kind of gets it, right? At 200 tokens per second, it's lickety split. Let me show you. You are a Canadian author and digital entrepreneur. You've written several successful novels. No idea who he is. But you can kind of understand, like, we can hit some problems with the token hammer over and over and over again. But these models, even the surprisingly small ones, are kind of capable. It's really surprising. So let's talk about some more benchmarks here. These are more realistic models, I would say. So like Nemotron 3, 4 billion parameters. This was running on my RTX 4070 Super at home. This is doing 136 tokens per second. Nemotron loves emojis. So if you want code with emojis in it, that's great. Prism, ML, Bonsai, 27B. That's a Qwen quantized. Running at 15 tokens per second. It's kind of slow. But look at this size, 8.8 gigabytes. Does anybody in here have a laptop that's like less than 12 gigs of RAM? No? So you can run it. You have no excuse. Awesome. That's right. If you have a gaming GPU or whatever, and it has more than 8.8 gigs of VRAM, you can run this, and you'll get more than 15 tokens per second. I'll tell you that. Like I was saying, Gemma 4 has a bunch of flavors. You can see that, remember when people joked about like GPT 3.5, March 2025. This is even worse. 426B A4B QAT star. But it's a little bit faster. It's a little bit bigger. Still runs on my MacBook. And then Gemma E4B, effective 4 billion parameters. That means at a time, 100 tokens per second, around 8 gigabytes still. These are all pretty good. Yes. That's true. Yes. There was a time when 3060s or 2060s 3060s only sold. They sold like two variants. One was like 8 gigs, and then one was 12 gigs. And they made the 12 gigs to rip off people. But actually, now it's a good deal. Thank you. All right, so let's talk about hardware requirements a little bit more. The best is if you have a dedicated GPU, right, with enough VRAM. A better setup is unified memory system. So that's something like a MacBook, right, where you have your SoC and your RAM is all together. When you're running a MacBook setup, use something called like a MLX. That stands for Metal, the Apple GPU accelerator. And then good is like a modern CPU. You can do this all without a GPU also. You can do a modern CPU with like lots of system memory. And then I have this old rack server at home that I was so excited. It has like 192 gigs of RAM. And it has dual core or dual socket Xeons. And I was like, dude, this thing's gonna be awesome. It's got 48 cores. It doesn't have vector instructions to run language models. So unfortunately, I can't do that. Yes. NPUs, TPUs, stuff like that. I feel like the drivers, I don't really know. The drivers aren't ready yet, so I don't think there's models that. Yeah, thanks. The other thing I will say is like the weirder you get, the less support you'll have, and just it's a terrible experience. So try to stick with like GPU or like a unified memory machine. Cool. So I want to talk about my inference setup for this sort of experiment. I use LM Studio. Has anybody heard of LM Studio? Okay, plenty of people. Great. It's basically just like if you've heard of Open UI, Web UI, it's a ChatGPT kind of interface, but this bundles up Llama and different inference engines together and lets you run it on your hardware. So um, it's super easy. You just download it, and they have a model search. You can just download the models right away. So if I wanted to download Qwen 3.8, that's great. It comes with it like starts a server also that's OpenAI Anthropic API compatible. So you can then build your harness off of that, and it's great. Then you can have your chat here. They have a mobile app as well. So awesome. And then I use my custom harness or whatever harness I'm using that day, right? Um, so a harness is just orchestration / tools surrounding a model. And let's talk about a little bit more of harnesses. So I think there's a problem, and I call it small model big harness, where you put these small models into a big harness, and it might not feel like a big harness, but it really is for these little guys. They kind of struggle. So let's go over what we kind of see. Pi is known to be like a really minimal harness, right? As I think they brag about how long their system prompt is and how they don't have subagents and all these things. It's a great harness for larger models. If I run Gemma 4 in Pi or Bonsai 27B, Gemma 4, I gave it a prompt. This was my eval for this. Is make a cross stitch pattern website. My wife likes cross-stitching, so, you know, make a website where people can download a cross-stitch pattern or upload a photo. So given that prompt of like a 4 sentences-ish, Pi comes up with the default the default like bun create React app. With Bonsai, a bigger model but more quantized, it won't even launch the dev server. It won't compile. Okay. So if we move to, let's talk about the failure modes. So why does it do this? It kind of lacks thoroughness. It doesn't check its work. It doesn't go through and validate that the edits took place, right? So we were seeing lots of failed tool calls where it tries to edit a file that doesn't actually exist. Working directory complications, meaning it thinks it's in a directory that it's not in, and so it tries to CD around and move around, just not good. And then low confidence, I will replace the entire file. It will like edit everything, and it'll maybe be good, and then it'll be like, oh, my next edit, that failed because it like missed the file. I'm gonna replace the whole file, and then that's probably how we got back to just, the default starting page for Next.js. All right, so OpenCode. OpenCode used to be like the most minimal one, and but now people say it's bloated, which is pretty funny. And it kind of is in some contexts, but with Gemma, OpenCode, it can launch the dev server, but we get an error when we load. With Bonsai, we see we're missing CSS. And, it's not like I just run these once. I ran these a couple hundred times. And I just want to pick out some of the best examples. And then Bonsai with a little bit of agents.md, which is where I started this project. Like, how good can we get with an agents.md? We actually did pretty good here. We can see, like, this looks like a cloud website, right? It's probably been distilled. All right, so what were the OpenCode failure modes? Sometimes it's overly thorough. It will make an edit and then check its work, and just get in a doom loop, right? Context rot. Small models are super susceptible to context rot. It'll edit a file, and then it won't remember what the file changed to, and then it'll think like, well, I read the file earlier. It's still like that. I got to edit it again. And it gets into an edit loop. And OpenCode has a nice thing where it says like, hey, before you edit the file again, you got to read it because it changed. But that bloats the context even more. So, and then another funny thing is it was super lazy. I'd say, hey, do this thing. And it's a great idea. I'm excited to see what you come up with. Not expecting to write code itself, which is pretty funny. So let's talk about harness theory and how we can do. I'm not training LLMs, right? I'm not that kind of guy. I'm kind of just interacting within the prompt. But to understand harness theory, we got to go back in time again. I remember in college using tab 9. Does anybody remember tab 9? They're still around. No? One head. Okay. They were the original tab to complete that was powered by AI. The Da Vinci models, okay? It was actually pretty good. You could write in like a comment that says like, tell me a joke, and it would spit out a joke. That was pretty good. Okay, and then the GitHub Copilot beta. Who was a member of the Copilot beta? Wasn't that awesome? You were on the beta, nice. In Vim, I was in VS Code. I hadn't started my Vim journey yet. Then ChatGPT releases. And then we get Cursor, we have Klein, Claude Code, we know the story. I think small local models are still somewhere in this area. They have the tool calling capabilities now, which is great. But they're in between like when ChatGPT released and like when Cursor started going like full agent-ish and like some of the better tab completes. So does anybody remember doing this? You copy your code and then you put it into ChatGPT and then it would fix the function. It was like, by function. It sucked, but it worked really well, right? Like I remember writing Rust on like the original ChatGPT 3.5, and you copy paste all day long, and it'll get it spot on. It doesn't have an LSP, it doesn't have a compiler, it doesn't have any checks, but it worked pretty well. So how can we emulate? I think, since the models are still in that kind of era when you run them locally, how do we emulate that early AI coding? And I think there's two ways. First way is orchestration. So this kind of handles the thoroughness problem, the context rot, and the laziness. What do I mean by orchestration? It just means putting kind of guardrails and steering the model in a deterministic way down a certain task, right? So the most simple one, and it's like, this is intuitive. Plan, execute, validate, summarize, right? That's a very basic orchestration component. So I tried a bunch of different techniques, you know, high detail planning, go and plan very in depth, you know, plan out to the function level, plan out to the package level, all these things. That didn't work very well. Extreme sub-agents. So like everything needs to be a sub-agent so you can like amass a massive amount of context, summarize it, and bring it back up. It doesn't work super well, unfortunately. Function level edits, kind of trying to emulate what we were getting with copy this function, put it into ChatGPT, and then get out a better version. That one is really hard to orchestrate because to get an LLM to break down a file into different functions, you know, nicely and then pull those edits back in properly is pretty hard. Clean room editing, which is where every edit tool call is actually a whole new thread, basically a sub-agent. And what I landed on, you know, for the least amount of work and best results is like selective amnesia is what I call it, right? So what that means is the agent will go make an edit. We're really careful to avoid context rot. If the edit fails a validation stage, we're going to erase that edit, erase what part of the model, not part of the model, erase what kind of reasoning the model came up with to come up with that crappy edit and steer it again in a new direction. So it's like it never tried it. And we preserve the context in that way. And I find that really works pretty well. The other thing is tooling. Has anybody actually looked at, well, I'll save it. So tooling is just like structured output and then, you know, handling that sort of deal, making sure that these models can actually spit out the thing you want so that you can orchestrate it more easily. And then tool use failures, those are so annoying, right? Like I mentioned, it's trying to edit the wrong file in the wrong directory, whatever it may be. Does anybody know actually how like the edit file in Claude Code works, that tool? It's so, you would never write code this way. It's a find and replace, right? So you put in the exact string you want to replace, and it finds it, and then you put in the exact string you want to replace. And it's like, who would write code this way? LMs are trained off humans. You wouldn't want to write code this way. There are a lot of interesting different edit tools. One that I find that is really interesting is hashline edit. So this hashes every line in the file. And it makes sure that when the LLM asks, hey, I want to overwrite this line, this is the hash that I think it is. This is the hash I want to overwrite. And then here's the text I want to replace it with. So that way, every time the file changes, that hash line is invalidated, right? And so the model can instantly know, oh, this line is out of date, or I missed it, but I can identify it by like just like a 4-character hash, which is really nice. There is a really great paper, if you look at, not a paper, it's an article, excuse me, about hashline edit and how it boosted model performance across multiple different harnesses, even with large models. I think it like made Grok more, like 30% more token efficient, which is insane to me. I made some other custom tools. One I call is tree. It's just like the tree command in Unix. It just like prints out really cleanly all the files in a directory. Give that to an agent because they always use ls and then it gets messy and then they don't know what changed. Dream is like Claude Code Dream, right? Big overarching architectural decisions that get captured about a project. And then I mentioned creating kind of artifacts or structured output surrounding a workflow. And so there's a plan create. This creates an actual plan document that can then, it's like the to-do in Claude Code. And then dedicated tools for building and testing the project. That the model, when it boots up, bootstraps, finds the commands to build and test. And so it can just, instead of fiddling around with bash and making sure that it doesn't nuke my computer, it can just call the build tool or the test tool and run the tests. And that's, these models are like babies, you know? you got to help them out as much as you can, and having those kind of captured away so they don't have to run a bash script is really handy. So don't. I run dirty. Yeah, so I use an SSD and I plug it in every week with Time Machine to make sure, you know, if anything ever does happen, I can get it back. So how I define local coders workflow is it's in Lua. I love Lua. I already mentioned it earlier, but there is a workflow orchestration layer that lives over all the agents, right? So an agent is defined as a Lua file, which is just a prompt, and then a tool set, right? And so you can bring those Lua files as an agent into another Lua script or function, and you can deterministically orchestrate over those different agent steps, and you can emit context, you can erase context, you can manipulate it between agents, and the agents can also, spit out artifacts in Lua and capture them, which is super nice. So this workflow says, hey, you're going to run a planning agent, you're going to have these plan tools, and then we're going to pull out the planning artifact, we're going to validate it, whatever, and then we're going to go to the implementer, it's going to have these tools, and then it's going to have a reviewer with validation tools, so on. This is all pretty basic, right? But this isn't built into any harness per se that, like OpenCode or Pi, they don't have these sorts of things. You kind of have to manually say, hey, I'm in plan mode, now I'm in build mode, etc. This just makes it a one-shot kind of deal. And so the default workflow is you bootstrap, you find those build and test commands, we save them in the tools, we plan, we implement, we review. If the review rejects, we steer and revise the context, we give it amnesia, we eliminate the bad editing from history because of that context rot. And once we're approved, if any architectural decision or whatever was made, big, large context that persists over the project, we're going to refresh the project context using the dream tool. Okay, any questions about that? It's pretty simple. Yeah, so an agent just has like its chat thread, right? And so we look for the last time that the edit tool was called, and we say, so we've invalidated that the edit was bad. We've validated it's bad. We're going to say, we're going to delete everything in the chat thread up to that edit tool and just blank that out, and then we're going to put in a steering command that is worded in a way that's like, hey, actually, I think you should do this instead before you edit it. And then it runs the edit command again. Does that make sense? Yeah. Yes, but with the important caveat of I'm eliminating the failed step. Yeah, no history. Exactly. Yeah, it's like a fork. Yeah. Yes. Yeah. Time machine is more accurate. Yeah. Yeah, good questions. Anything else? Cool. All right. So bootstrap plan. I mean, this is just more detail, right? So getting the dream and the validation. This just holds like the commands for the build and test tooling, and then we receive the task plus the dreams, just a system prompt, right? We inspect the files. Yeah, yeah. You know how a coding agent works. Okay, cool. And then the implementer sees that it has context of the task. It looks at a git diff of what. Sorry, I forgot to mention this. We start a git checkpoint, right before we do the edits. So the edits can be reverted also, right? Not just the chat, but the edits will be reverted, and then we can review and iterate on that. Okay, cool. This is so funny. No white space errors. Who cares about white space errors? So yeah, the implementer. Yeah, so the implementer will make sure that you're on like a clean Git branch, and then the reviewer will see just like it will see the task. Right, it's not even going to see the edit history. The reviewer is going to see the task, the plan, and have access to the code base alongside a Git diff output. Exactly. Yep. 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 The edit failed. Hey, git restore. we're going to restore the chat history as well, and we're going to put in some steering direction to make it think a little bit better. Yeah, it's undo. Yep. I should have said that. Next time, I'll put it in my slide. Thank you. Yeah, so then we have the reviewer, git diff, check results, validate, test build. Both must be true, approve, and the git diff, check. And then, yeah, 2 or 3 tries and the third rejection fails. 3 strikes and you're out. And yeah, we went over the project dream refresh, right? Anything durable change for the next iteration. Okay, so this is the output of local coder with that workflow on Bonsai 2027B. It's pretty good. For a free model, that's pretty good. One of the things that you can notice is, was that? She was like, there's a million websites. I'm not going to use this, so. I mean, it's whatever. No hard feelings from her. But one of the interesting things is this ran for probably about an hour. That's a long time. But OpenCode would run for 2 hours and then fail. So this is a good improvement, I would say. So that's Bonsai 27B. That's a more capable model. This is Gemma. Now, if you remember, Gemma didn't finish ever on the other harnesses, but this is dog ugly. This is bad. But it actually works, right? It actually compiles. It actually comes up online. This is out of spec. But for a one-shot, this is pretty good, I would say, for a local model. Like I said, we don't have Fable at home, but this is a great starting point. If you actually read the code, you can steer it in a way that you need to get these things fixed. You can change the colors, etc. All right, cool. So for future improvements, there's lots of things to improve here. We only really went into like some custom tools and some workflows, and we still got a lot of gain. But with the workflows, you can balance your speed and your iterations. Oh, the other thing I forgot to mention, speaking of speed, Gemma runs so fast. This spat out in like lickety split, just a couple minutes. Visual validation and computer use. There's local models now that will be able to do vision, like Quen. So on top of like deterministic, will this compile or not? You can put in a screenshot from your browser. I talked about how subagents really didn't work, and we've learned about this from Anthropic previously. Agents have a really, LLMs, I should say, have a really hard time conceptualizing and managing subagents and like communicating with them. We're seeing new things with like the OpenAI hack where they're getting better, and we also see like Moltbook where they're communicating more, but like really in-depth orchestration between themselves is still not really there, especially with these smaller models. So inter-agent communication, I think, could be sorted out with a few more tools. And then number 4, we can just wait for better models. A better model is probably going to come out next week. So here's what I'll say. 2026 is the year of build your own harness, so try it. If you're going to do it, try the Quen models because you're going to get disappointed by any of the other ones first. So I think it's good. And then if you really want to code and you value your time, just get the GPT subscription for $20 a month, and you can use Luna, and it's fantastic. That's actually my daily driver. I don't actually code daily with local models here. So yeah, that's it. Yeah. I'm not familiar with that now. Okay. Yeah. Lua is so fun. Lua is so cool. It's fast. It's, Oh, with Lua? No. There's a really good Rust package called mlua that is a Lua interpreter inside of Rust. That's fast enough. So that part is really great. Just-in-time compilation and or just-in-time interpretation, and being able to write an agent as a file, a Lua file, and then like import that as code and then manipulate it and mess with the fields at runtime is like fantastic. Todd and I have argued about Lua a lot though, but Lua is a really cool place to get into scripting, and I think it would be a really great language to build agents on if it had more package support. But RIP. Another thing I wanted to say is like you can look at these different, excuse me, you can look at these different websites and like people that are doing startups and oh, where'd it go? Oh, excuse me. Like somebody came out with like what they call a recursive LLM or RLM the other day, and it's just a it's just an LLM with a context window that's put into a variable that it can like programmatically access through Python. It's like people are making up so many different and new things, and it sounds way bigger than it actually is. But I think there's a lot of alpha to be had with making custom tools for models, and you can go pretty far. So